Imagine walls of stone locked so tight a knife blade cannot slip between them, yet they flex and dance through earthquakes. Precision-cut H-blocks at 13,000 feet with tolerances thinner than a human hair. No wheels, no steel. An entire city carved 18 levels deep. Ventilation for 20,000 people. Rolling stone doors that only open from the inside. Pyramids that encode the cosmos. Cliff cities hanging 90 feet above the canyon floor. An industrial army of 8,000 clay soldiers. These were not built by chance. According to everything we know about ancient technology, they shouldn't have been possible.
What if I told you that beneath our cities, beneath quiet villages, beneath windswept deserts, there are entire worlds hidden underground? Not caves carved by nature. Cities, temples, water systems, secret passageways. Some could shelter thousands of people. Others were built with astonishing precision thousands of years before modern machinery. A few are so mysterious that archaeologists still can't agree why they were created. And here's the strangest part. These underground worlds weren't built by one civilization. They appear again and again across history, separated by oceans, languages, and centuries. So why did humans keep digging? Today we're counting down 10 of the most remarkable underground structures ever discovered, and by the end, you may see these hidden worlds very differently.
Every civilization leaves something behind. Egypt left pyramids, Rome left roads, the Maya left towering temples. But some of humanity's greatest achievements were never meant to dominate the skyline. They disappeared beneath it. As an architect, I've always been fascinated by the challenge of building underground. Above ground, gravity is your enemy. Underground, the earth itself becomes both your greatest obstacle and your strongest ally. Temperature remains remarkably stable. Thick walls of rock provide natural protection. Water can be collected, stored, and controlled. It's no accident that people have been drawn below the surface for thousands of years, yet these places raise as many questions as they answer. Some were built to survive war. Others became sacred spaces. Some remain so mysterious that no written record explains who built them or why. As we count down from 10 to 1, you'll notice a pattern emerging. Each structure reveals another reason humanity has always looked beneath the earth, not simply to hide from the world above, but to create something that could endure. Let's begin in an ordinary French village where extraordinary secrets waited just below the streets.
From the surface, Naours looks like a peaceful rural town in northern France. Stone houses, narrow streets, church spires, nothing suggests that beneath the village lies an astonishing underground refuge. Carved into soft chalk over many centuries, the underground city contains hundreds of interconnected chambers, linked by passageways stretching for miles. Families could disappear below ground with livestock, food, and supplies whenever invading armies swept across the countryside. For generations, these hidden rooms offered safety during conflicts that repeatedly scarred Europe. Entire communities simply vanished from sight until the danger passed. Today, wandering its dim corridors, it's hard not to imagine the silence that once filled these tunnels as people waited in darkness, hoping the sounds of war would fade above them. The underground had become humanity's oldest fortress. Not every remarkable underground world belongs to the distant past. During the Vietnam War, the Chu Chi tunnels became one of history's most extraordinary examples of survival beneath the earth. More than 150 miles of tunnels connected command posts, hospitals, kitchens, storage rooms, and living quarters. Entire communities operated almost invisibly below ground while conflict raged overhead. The conditions were unimaginably difficult, cramped passages, little fresh air, constant danger, but the tunnels demonstrated something our ancient ancestors already understood. When the world above becomes too dangerous, people instinctively look below. Separated by thousands of years from ancient underground cities, Chu Chi reminds us that this instinct has never really disappeared. If the first underground worlds were built for protection, the next one may have been built for something even more profound. On the Mediterranean island of Malta lies the E. Saflieni hypogeum, carved entirely beneath the surface more than 5,000 years ago. No towering columns greet visitors. No grand facade announces its presence. Instead, narrow stairways descend into carefully sculpted chambers whose walls still bear traces of ancient red ochre decoration. Some rooms possess remarkable acoustic qualities. A single voice can resonate through the complex in a way that feels almost supernatural. Was this a temple? A burial site? A place where ritual and architecture combine to create experiences impossible under the open sky? No one knows for certain. But one thing is clear. By this point in history, humans weren't simply hiding underground anymore. They were choosing it.
We've already seen three very different reasons people went underground. First for protection, then for survival, and finally for something deeply spiritual. But what comes next surprised me the most. Some civilizations weren't simply carving out hiding places or sacred chambers. They were undertaking engineering projects so ambitious that even today, archaeologists aren't entirely sure why they were built. The deeper we go into this countdown, the less this becomes a story about escaping the world above. It becomes a story about creating entirely new worlds below it.
Imagine removing nearly 1 million cubic meters of solid rock. Now imagine doing it over 2,000 years ago, without explosives, without modern machinery, without leaving behind a single written explanation. That's the mystery of China's Longyu Caves. Discovered only in 1992, after local residents drained several ponds, the site revealed 24 enormous underground caverns, each carved with strikingly consistent parallel chisel marks. Massive stone pillars support ceilings soaring more than 90 feet overhead, evidence of careful planning and remarkable craftsmanship. The engineering alone is astonishing. Excavating this much rock would have required an enormous workforce and years of coordinated effort. Yet, history is silent. No inscriptions, no surviving records, no clear purpose. Storage? Quarries? Military shelters? Ceremonial halls? Every theory answers some questions while creating new ones. Sometimes the greatest mystery isn't how something was built. It's why anyone decided to build it at all. If you've ever stood inside a great cathedral, you know the feeling. Towering columns, cool air, soft echoes. Now imagine finding one hidden beneath the streets of a bustling city. That's exactly what awaits beneath Istanbul. Built during the reign of Emperor Justinian in the 6th century, the Basilica Cistern was designed to store and distribute water for the imperial capital. More than 300 marble columns rise from dark water, supporting a ceiling that seems to disappear into shadow. Everything about the space feels sacred, yet its purpose was entirely practical. The Byzantine Empire understood that cities don't survive on monuments alone. They survive because people have clean water, especially during droughts and sieges. Today, reflections ripple across the water while visitors walk elevated pathways through the dimly lit chamber. It's one of history's greatest reminders that extraordinary architecture isn't always built to be seen. Sometimes the most important buildings are the ones hidden from view. Most people know Petra because of one breathtaking image. the treasury emerging through a narrow canyon in the Jordanian desert. But that famous facade tells only part of the story. Petra wasn't simply carved into cliffs. It was engineered around an entire landscape with sophisticated systems for collecting rainwater, controlling floods, storing water underground, and supporting tens of thousands of inhabitants in one of the driest environments on Earth. Beneath the city's spectacular monuments lies an equally impressive network of cisterns, channels, reservoirs, and carved chambers that made life possible. Without this hidden infrastructure, Petra could never have flourished. It's a reminder that civilizations often owe their success not to the grand structures everyone remembers, but to the invisible systems working quietly beneath them. Some underground spaces were planned, others simply grew. For nearly 3,000 years, the people of Orvieto, Italy, kept digging. One generation carved a well, another added wine cellars. Later came storage rooms, escape passages, workshops, cisterns, olive presses, pigeon lofts, and tunnels connecting neighborhoods. Each generation inherited the work of the last, then added something of its own. The result isn't one grand design. It's an underground history book. Walking through Orvieto today feels like peeling back the pages of time itself. Every tunnel belongs to a different chapter in the city's long life. It raises an intriguing thought. Perhaps humanity doesn't always build underground because of one great idea. Sometimes we simply keep solving one practical problem after another, until centuries later we discover we've built an entire hidden world.
So far, every underground world we visited has answered a practical need: protection, water, storage, engineering, entire communities. But the final 3 entries suggest something more. Many ancient cultures believed the earth itself held power. To descend beneath the surface wasn't simply to enter another room, it was to cross a threshold. The darkness, the cool air, the silence, all combined to create an experience unlike anything possible beneath an open sky. Whether those beliefs were spiritual, psychological, or simply brilliant architecture is still debated. What isn't debated is this: the deeper we descend into history, the more the underground begins to feel intentional, not as an escape from the world above, but as a destination in its own right.
High in the Andes of Peru lies one of South America's oldest ceremonial centers, Jardín de Huántar. From above, it appears impressive enough, but the real experience begins below ground. Hidden beneath the stone temples is a labyrinth of narrow galleries, twisting corridors, ventilation shafts, and chambers carefully designed to disorient visitors. Light disappears. Sound behaves strangely. Passages tighten and then suddenly open into larger spaces. Archaeologists believe priests may have guided pilgrims through these dark passageways during elaborate religious ceremonies. The journey itself became part of the ritual. Some researchers suggest the architecture was deliberately crafted to inspire awe, fear, and transformation. The underground wasn't merely housing religious practices, it was helping create them. Long before modern psychologists understood how environments influence human emotion, these builders may already have grasped that architecture could shape the mind. As someone who spent a career designing buildings, I find that idea remarkable. Sometimes architecture isn't about providing shelter. Sometimes it's about creating an unforgettable experience. If someone described an underground city with schools, churches, kitchens, wine cellars, wells, livestock pens, storage rooms, ventilation systems, and enough space for 20,000 people, you might assume it belonged in a fantasy novel. Instead, it exists beneath the volcanic landscape of Cappadocia in central Turkey. This remarkable region contains dozens of underground cities connected to one another, each expanding over centuries as communities adapted to changing threats. Ingenious ventilation shafts delivered fresh air deep underground. Massive circular stone doors could seal entire sections against invaders. Food, water, and livestock were all carefully planned to support extended stays beneath the surface. Life didn't stop underground. It simply continued. Walking through these passages today, it's impossible not to admire the planning involved. Every hallway, chamber, and shaft reflects careful thought about how real people would actually live. For an architect, it's a masterclass in designing within extraordinary constraints. For everyone else, it's proof that human ingenuity rarely accepts impossible as the final answer. And yet, even Cappadocia isn't the most astonishing place on our list. Imagine living your entire life without seeing daylight for weeks. Children playing in underground rooms, families sharing meals, animals housed nearby, churches holding services, workshops producing tools, fresh air flowing through shafts carved deep into the rock. Now imagine this wasn't one neighborhood. It was an entire city. Welcome to Derinkuyu. Discovered almost by accident in the 1960s when a homeowner knocked down a basement wall, Derinkuyu descends at least 8 levels beneath the earth, with some researchers believing additional unexplored sections may still exist. At its peak, as many as 20,000 people may have sheltered here, along with livestock and supplies. The city contains everything a community required to survive. Kitchens, wineries, schools, churches, wells, storage chambers, meeting rooms, and a sophisticated ventilation system that still impresses engineers today. Massive stone doors weighing hundreds of pounds could be rolled into place to isolate different levels from attackers. Standing inside Derinkuyu today, it's difficult to think of it as merely an underground refuge. It's an underground civilization. Thousands of years ago, without steel, concrete, or powered equipment, people imagined an entirely different way to inhabit the earth. Not on it, but within it. For me, that's what makes Derinkuyu one of the most extraordinary architectural achievements in human history.
When we began this journey, the question seemed simple. Why did people build underground? Now I think the answer is far richer. Sometimes they were escaping danger, sometimes they were protecting precious water, sometimes they were creating sacred places, sometimes they were solving practical problems one generation at a time, but beneath all those reasons lies something even more fundamental. Human beings have always adapted. Give us mountains, and we'll carve cities into them. Give us deserts, and we'll build hidden reservoirs. Give us hostile landscapes, and somehow we'll find a way to call them home. Perhaps that's why these places continue to fascinate us. They're more than archaeological sites. They're monuments to imagination. They remind us that our greatest strength has never been the world we inherit. It's the world we're capable of creating. So the next time you walk through an old city or across an empty field, remember this. There may be another world beneath your feet, waiting patiently for someone curious enough to discover it. If you enjoyed this descent into history, I'd love to know which underground wonder amazed you the most, or if there's another hidden world we should explore in a future episode. Here at Dave's Curiosity Lab, curiosity always leads to another adventure, whether it's above ground, below ground, or somewhere history forgot to mention. If that sounds like your kind of journey, subscribe, and I'll see you in the next deep dive.
High in the Bolivian Andes sits one of the strangest archaeological sites on Earth. Massive stone blocks weighing over 100 tons, precision cuts that still spark debate, and a mystery that has challenged archaeologists, engineers, and researchers for decades. How was Puma Punku really built? And what if we've been asking the wrong question all along?
Welcome back to Dave's Curiosity Lab. Today we're heading high into the Bolivian Andes to investigate one of the most puzzling archaeological sites in the world, Puma Punku. For more than a century, researchers have debated how these massive stones were quarried, transported, and shaped with such remarkable precision. Mainstream archaeology credits the achievement to the Tiwanaku civilization. Others believe there may be more to this story. Now, I'm not an archaeologist. I am an architect. After 40 years in design and construction, a few things about Puma Punku immediately catch my attention. Let's take a look at the evidence and see where it leads.
To understand the mystery of Puma Punku, we first need to understand the place itself. The site sits on a windswept plateau in western Bolivia, just a few miles from the southern shore of Lake Titicaca. At nearly 12,800 feet above sea level, the air is thin, the climate is harsh, and even simple physical labor can be exhausting. Today, Puma Punku appears as a field of scattered stone blocks. At first glance, it may not look particularly impressive. There are no towering pyramids, no standing columns, and no massive walls still reaching toward the sky. But appearances can be deceiving. Puma Punku was once part of a much larger ceremonial complex connected to the nearby city of Tiwanaku, one of the most important civilizations in pre-Columbian South America. Long before the rise of the Inca Empire, the Tiwanaku people built a thriving culture in this high-altitude environment. Archaeologists believe the civilization flourished between roughly 500 and 1000 AD, becoming a major political, religious, and economic center for the region. What remains today are the fragments of a monumental construction project. Some of the largest red sandstone foundation blocks weigh more than 100 tons. These stones were transported from quarries estimated to be several miles away. Even more remarkable are the gray andesite blocks found throughout the site. Many researchers believe these stones originated from sources much farther away, possibly across Lake Titicaca and more than 50 miles from Puma Punku itself. Moving stones of this size would be a formidable challenge even with modern equipment. Yet transportation may not be the most impressive part of the story. As researchers began studying the site more closely, they noticed something unusual. Many of the stones appeared to have been shaped according to a consistent plan. Instead of rough construction, there were repeating forms, carefully cut surfaces, and evidence of sophisticated stoneworking. One particular design appears again and again throughout the site, a distinctive H-shaped block. These stones seem almost modular, as though they were intended to fit together as components within a larger engineered system. Exactly how advanced were the builders of Puma Punku? Because the closer researchers looked, the stranger the site became.
Puma Punku may never give us all the answers. Whether these stones were shaped with extraordinary craftsmanship, innovative techniques we've yet to fully understand, or methods that have simply been lost to time, one thing is clear. The people who built this place were far more capable than many of us imagine. As an architect, that's one of the lessons I take away from sites like this. Every generation tends to assume it has all the answers, only to discover there is still much left to learn. Perhaps the real mystery of Puma Punku isn't how it was built. Perhaps it's much of the knowledge can be gained, lost, and forgotten over the centuries.
The deeper researchers looked at Puma Punku, the more unusual the stonework appeared. Perhaps the most famous features of the site are the so-called H-blocks. These distinctive stones appear throughout the ruins and share a remarkably consistent design. Each contains a complex combination of right angles, recesses, channels, and interlocking surfaces. While no two are perfectly identical, many appear to follow the same basic template. The result is a structure that feels surprisingly modular. Rather than shaping each stone independently, the builders seem to have worked from a common design language, producing components intended to fit together within a larger architectural system. For ancient builders, that level of standardization is noteworthy. But the H-blocks are only part of the story. Throughout the site, researchers have discovered evidence of sophisticated joining techniques designed to hold massive stones together. Carved into many blocks are carefully shaped recesses known as dovetail sockets. These cavities once held metal clamps that bridged adjacent stones. Archaeological analysis has shown that many of these clamps were made from a copper-based alloy containing arsenic and nickel. Molten metal was poured directly into the prepared sockets, creating custom-fitted connectors that helped stabilize the structure. In an earthquake-prone region, it was a remarkably effective engineering solution. The builders were clearly thinking about more than simply stacking stone. They were designing a system. Then, there are the cuts themselves. Walk among the ruins and you'll find sharply defined corners, flat surfaces, narrow grooves, and precisely carved channels. Some features appear almost machine-like at first glance, leading many visitors to wonder whether the stones were worked with tools more advanced than archaeologists currently recognize. Most experts reject that conclusion. They argue that skilled craftsmen, working with stone hammers, abrasives, and enormous amounts of labor, were capable of producing results that appear surprisingly precise to modern observers. And in many ancient cultures around the world, extraordinary craftsmanship has often been mistaken for advanced technology. Still, certain details continue to generate debate. Some researchers point to drill holes that display circular patterns and consistent geometry. Others note the apparent uniformity of certain cuts and surfaces throughout the site. None of these observations prove the existence of lost technology, but they do raise an interesting question. If the builders achieved this level of precision using the tools archaeologists believe were available, what exactly would that process have looked like?
This is the point where the builder in me starts to ask questions. The mainstream explanation is that the stones at Puma Punku were shaped using hammerstones, simple bronze tools, and abrasive materials such as sand. Now, ancient craftsmen were often far more skilled than we give them credit for. Human beings can accomplish remarkable things with simple tools and enough time. But when we look at some of these cuts, channels, and repeating forms, I naturally wonder about the process. How many workers were involved? How long would it take to produce a single block? How were consistent dimensions maintained across multiple stones? And perhaps most importantly, how did they ensure the individual pieces even fit together within a larger architectural plan? In construction, precision is rarely accidental. It usually comes from a combination of planning, measurement, and repeatable methods. The real mystery may not be whether the builders were capable of creating these stones. The mystery is understanding exactly how they did it. And that's where the competing theories begin.
So how was Puma Punku actually built? The simplest explanation is also the one accepted by most archaeologists. According to the conventional view, the Tiwanaku people quarried the stone, transported it using human labor, shaped it with hammerstones and abrasive techniques, and assembled the complex over many years of skilled work. There is nothing supernatural about this explanation. No lost civilization, no advanced machinery, just human ingenuity, organization, and patience. And history provides many examples of ancient cultures accomplishing extraordinary feats with surprisingly simple technology. But for some researchers, questions remain. One alternative proposal is known as the geopolymer theory. Supporters of this idea suggest that at least some of the stone elements may not have been carved at all. Instead, they argue that ancient builders could have created a type of stone-like material, poured it into molds, and allowed it to harden. If true, that would help explain the repeating forms, sharp internal angles, and consistent dimensions found throughout the site. The theory has attracted interest from some material scientists, but it remains highly controversial. Most archaeologists continue to conclude that the stones are natural rock that was quarried and shaped rather than cast. At the moment, the evidence remains open to interpretation. Then there is the question of what happened to Puma Punku. Today, the site appears shattered. Massive blocks lie scattered across the landscape. Some are overturned. Others seem displaced far from where they were originally intended to stand. Over the years, researchers have proposed several explanations. Earthquakes may have damaged portions of the complex. Centuries of weathering certainly played a role. Human activity likely contributed as well, as later populations reused stones from older structures. Others have suggested that major flooding events in the Lake Titicaca Basin may have caused significant destruction. Whatever the cause, the result is the same. We are attempting to reconstruct a story from fragments, and that may be the most important point of all. Puma Punku does not provide us with complete answers. Instead, it offers clues. Some support the conventional explanation. Others continue to raise difficult questions. And perhaps that is why the site remains so fascinating. Not because we know exactly what happened here, but because we don't.
Puma Punku may never give us all the answers. Whether these stones were shaped with extraordinary craftsmanship, innovative techniques we've yet to fully understand, or methods that have simply been lost to time, one thing is clear. The people who built this place were far more capable than many of us imagine. As an architect, that's one of the lessons I take away from sites like this. Every generation tends to assume it has all the answers, only to discover there is still much left to learn. Perhaps the real mystery of Puma Punku isn't how it was built. Perhaps it's how much knowledge can be gained, lost, and forgotten over the centuries. What do you think? Did the builders accomplish this through skill, organization, and persistence alone? Or is there still something important that we're missing? Let me know in the comments below. I'd love to hear your thoughts. And if you enjoyed this investigation, please take a moment to like and subscribe. Be sure to explore the rest of the channel as well. Here at Dave's Curiosity Lab, we are building a growing library of fascinating mysteries, remarkable discoveries, history, science, and ideas designed to help us better understand our world. Until next time, stay curious, keep an open mind, and learn something new every single day.
Ancient people separated by oceans and thousands of years all built the exact same massive structure, the pyramid. Did they share a secret blueprint, or is it simple physics? From the blistering deserts of Sudan to the dense jungles of Indonesia and the sprawling plains of Mexico, these mega monuments completely defy logic. Today, we are decoding the ultimate architectural mystery. We're tearing down the myths of lost technologies and exposing the brilliant, brutal engineering that raised these ancient giants. Let's dig in.
Welcome back to the lab. I'm your host, and as an architect, I look at the built world a little differently. When I see a pyramid, I don't just see a tomb or a temple. I see a massive logistical puzzle. How did Bronze Age builders manage tolerances tighter than modern skyscrapers? Why did unconnected civilizations across the globe independently arrive at the exact same geometric shape? Today, we are counting down 10 global sites to uncover how and why humanity became obsessed with building artificial mountains.
Coming in at number 10, the ziggurats of ancient Mesopotamia. Built as early as 4000 BCE, these step platforms were the architectural precursors to true pyramids. Lacking vast stone quarries, builders relied on sun-baked mud bricks to construct massive, receding tiers. Architecturally, this shape wasn't just symbolic of reaching the heavens, it was a structural necessity. To build high with fragile mud brick, you need an exceptionally wide, heavy base to distribute the crushing load. It's the pure physics of gravity at work. At number 9, we witness the evolution of the shape in Egypt. Around 2700 BCE, Pharaoh Djoser constructed the famous step pyramid, stacking stone mastabas to create a tiered monument. But it was Pharaoh Sneferu who pushed the engineering envelope, transitioning from step to smooth-sided structures. This required incredibly precise casing stones to lock the core rubble in place. The resulting geometry perfectly distributed internal thrust, ensuring these multi-million-ton limestone structures could survive tectonic shifts and millennia of erosion. Number 8 brings us to the apex of Egyptian engineering, the Great Pyramid of Giza. Constructing a 146-meter-tall monument with 2.3 million blocks required masterful logistics. Builders didn't just use brute force, they manipulated their environment. By pouring water onto sand, they reduced sledge friction by 55%. They also engineered massive dikes and canals, using the Nile's seasonal flooding to float heavy limestone blocks directly to the construction site. It wasn't magic, it was an impeccably organized parallel operations supply chain.
So the exterior was mastered through brilliant supply chain logistics and simple friction physics. But what about the interior? The precision inside these structures is what truly baffles modern machinists. Let's look closer.
At number 7, we tackle the Great Pyramid's King's Chamber. The massive granite beams here feature joints so flush you can't insert a razor blade. Early theorists assumed advanced lost technology because soft copper tools absolutely cannot cut granite. The secret was actually tribology. Egyptian engineers crushed corundum, a mineral second only to diamond in hardness, into an abrasive slurry. Guided by toothless copper saws and hollow drills, this corundum paste ground flawlessly through solid igneous rock, leaving unmistakable circular striations behind. Number 6 takes us across the globe to the America's oldest civilization. At Caral Supe in Peru, builders constructed massive pyramids around 3000 BCE, predating ceramics. Living in a highly active seismic zone, these architects developed a genius shock-absorbing foundation. They used the shicra technique, filling woven reed bags with loose rocks to create a flexible base layer beneath the pyramid. During an earthquake, these stones shift and absorb the seismic energy, preventing the massive stone terraces above from fracturing and collapsing. At number 5, we look at the Great Pyramid of Cholula in Mexico. While Giza is the tallest, Cholula holds the record for the largest pyramid by volume on Earth. Its base covers a staggering 160,000 square meters. Unlike the Egyptian models, Mesoamerican pyramids were often expanded sequentially. Over centuries, successive generations built entirely new, larger pyramid shells directly over the older structures. This continuous layering technique created an unimaginably massive footprint, eventually forming a structure that literally mimics a natural mountain. Coming in at number 4 is Teotihuacan, Mexico. Here, the pyramids of the sun and moon aren't just isolated buildings, They are masterworks of urban site planning. The city's architects used an architecture of horizons. The pyramids were specifically proportioned and positioned to visually echo the silhouettes of the distant mountains. As you walk down the Avenue of the Dead, the forced perspective constantly shifts, utilizing the pyramids to dramatically frame and mirror the sacred natural landscape standing behind them.
You see, the Mesoamerican approach was fundamentally different from the Egyptian. While the pharaohs built sealed tombs to protect the dead, the Americas built artificial mountains designed for exterior public rituals. But what happens when builders push the geometric limits?
At number 3, we head south of Egypt to Sudan, home to over 250 Nubian pyramids at Meroe. Unlike the 51-degree incline of Giza, these Kushite monuments thrust upward at an aggressive 70-degree angle. This incredibly steep, blade-like profile was a deliberate architectural choice, requiring a much smaller foundation footprint. Funded by a massive centralized iron smelting economy, the Nubian builders utilized attached mortuary chapels to balance the visual weight, perfecting a striking architectural proportion entirely distinct from their Egyptian neighbors. Number 2 takes us to the jungles of Southeast Asia. At sites like Kokher in Cambodia and Candi Suku in Indonesia, builders erected steep, stepped pyramids entirely independent of Egyptian or Mesoamerican influence. Using volcanic laterite and columnar basalt, these structures were designed as earthly reflections of Mount Meru, the cosmological center of the Hindu and Buddhist universes. To support these vertical loads, Asian architects ingeniously utilized interlocking cut stone retaining walls without relying on traditional mortars to maintain structural integrity. Finally, at number 1, Gunung Padang in Indonesia reveals the ultimate truth of the pyramid. While some claim it's a 27,000-year-old completely artificial construct, geological core drilling reveals it's actually a sculpted volcanic hill, enveloped in layered, man-made stone terraces. And that answers our core question: why pyramids? Before structural steel, if you wanted to build high to touch the gods, gravity demanded a wide base. The pyramid isn't a shared global blueprint. It is the universal convergent solution to the laws of physics.
And there you have it. The pyramid is humanity's ultimate triumph over gravity. From the wet sand transport of Giza to the seismic shicra bags of Peru, our ancestors were brilliant material scientists and master logisticians. No ancient aliens, no magic machinery, just pure human ingenuity pushing stone to the absolute limit. If you love diving into the structural secrets of the ancient world, make sure to smash that subscribe button. Next week, we're tearing apart the catastrophic engineering failures of ancient Rome. Stay curious. "2,000 years ago, an emperor didn't just build a tomb, he engineered a subterranean superpower. 8,000 soldiers, cast in clay and armed with lethal bronze, standing guard over a city we are still afraid to enter. From mercury rivers to metallurgy that shouldn't exist, this isn't just archaeology, it's a masterclass in ancient logistics. Today, we're decoding the engineering of the Terracotta Army. I'm an architect, and when I look at the Qin dynasty, I don't just see statues, I
I see a massive industrial challenge. To create the Terracotta Army, the Qin had to master mass production, material science, and seismic design on a scale the world wouldn't see again for 1,800 years. We're going beyond the surface to look at the tolerances, the chemical coatings, and the urban planning of a spirit city. Let's dive into the top 10 engineering marvels of the first emperor.
In 1974, local farmers digging a well accidentally breached a subterranean vault, sparking the greatest archaeological find of the 20th century. From an engineering perspective, the most impressive part isn't just the statues, but the fact that these pits, buried just meters below active farmland for 2 millennia, remained structurally sound. The sheer volume of earth moved to create these 20-foot deep trenches reveals a massive civil engineering project that was hidden in plain sight, perfectly preserved by the very soil the farmers were tilling. The soldiers aren't just mud, they are high-tech ceramics. Architects of the time used a specific local less soil, mixed with grit to control shrinkage during the drying process. Each statue was fired in kilns at temperatures between 900 and 1,000 degrees Celsius. This level of thermal control is incredible. If the temperature fluctuated even slightly, the hollow torsos would have shattered. This was a massive, state-sponsored material science operation, turning raw earth into eternal terracotta with industrial-grade consistency. Looking through an architect's lens, the pits themselves are a marvel of structural engineering. To support the weight of the earth above, the Qin used a system of rammed earth partitions, paved brick floors, and massive wooden rafters covered in fiber mats. This flexible design allowed the pits to survive numerous earthquakes over 2,200 years. The partitions acted as load-bearing walls, while the wooden roof provided a shock-absorbing canopy, creating a stable environment for the thousands of soldiers standing below.
Think about the logistics for a second. We're talking about 700,000 laborers. As an architect, I'm obsessed with the site camp required for this. Where did they sleep? How did they feed them? This wasn't just a construction site, it was a temporary city built solely to produce a permanent one for the dead. The project management here is actually more impressive than the art.
The Qin dynasty invented the modern assembly line. Each soldier was built using a modular system, interchangeable legs, torsos, and arms. There were 8 basic face molds, but artisans hand-sculpted unique features onto each one to create individual identities. To ensure quality control, every part was stamped with the name of the workshop or the foreman. If a part failed, the architect knew exactly who to blame. This was the first recorded use of standardized parts and industrial signatures for accountability. The army wasn't just decorative. They were armed to the teeth with functional, lethal weaponry. Excavations have revealed over 40,000 bronze arrowheads, spears, and swords. The most complex components were the bronze crossbow triggers, precision-cast mechanical devices made of 3 moving parts. These parts were produced to such tight tolerances that they were interchangeable across different triggers. This level of standardized manufacturing ensured that any soldier could be rearmed instantly, reflecting a military-industrial complex that was centuries ahead of its time. When the bronze swords were unearthed, they were still sharp and miraculously free of rust. Early chemical analysis found traces of chromium oxide on the surface, leading to the theory that the Qin had developed an advanced anti-corrosion coating 2,000 years before the process was patented in 1937. While modern researchers debate if this was intentional or a result of the soil chemistry, the metallurgical precision of the alloys, perfectly balanced for hardness and flexibility, remains an undeniable peak of ancient chemical engineering. When they were first born, these soldiers were vibrant, covered in brilliant reds, blues, and purples. The secret was a base layer of East Asian lacquer, a highly durable but temperamental polymer made from tree sap. However, this coating is the Army's greatest vulnerability. As an architect, I look at the sealant as a failure of preservation. Once exposed to air, the lacquer dries out and curls in seconds, pulling the paint with it. It's a tragic chemical reaction that modern engineers are still trying to solve.
Most people focus on the soldiers, but we have to look at the urban plan. The pits are just the barracks. The entire necropolis is a 22 square mile spirit city that mirrors the actual Qin capital. It's a perfect example of architectural symbolism. A ruler who believed that if he could build a precise enough model of his world, he could rule it forever.
The necropolis is a masterpiece of landscape architecture. It consists of an inner and outer city, with the emperor's tomb at the center of a north-south axis. The placement of the pits, infantry, cavalry, and the command center follows strict military formations of the era. This wasn't a random burial. It was a deliberate, scaled-down replica of the Qin Empire's capital, Xianyang. The orientation and symmetry reflect the Chinese concept of feng shui, aligning the emperor's eternal home with the cosmos and the Earth's natural energy. Ancient texts describe the tomb's interior as containing a miniature map of the empire, with rivers of mercury made to flow mechanically. For decades, this was dismissed as myth. However, modern soil probes have detected mercury levels in the tomb mound that are 10 to 100 times higher than normal. The engineering required to create a self-sustaining liquid metal hydraulic system is mind-boggling. It likely served a dual purpose: a beautiful symbolic landscape and a toxic pressurized deterrent for any would-be tomb raider. The greatest mystery remains the central tomb itself, which has never been opened. Architects and archaeologists are currently using non-invasive technology like muon tomography, using cosmic rays to see through stone, to map the interior without causing a structural collapse. The fear isn't just traps, but the immediate degradation of the artifacts once the 2,000-year-old atmosphere is breached. We are waiting for engineering to catch up with history, developing robotic systems that can enter and preserve the site simultaneously. The best is truly yet to come.
The Terracotta Army is a testament to what happens when absolute power meets absolute engineering. The Qin dynasty's obsession with standardization and logistics didn't just build an army, it built the blueprint for the modern world. If you found this deep dive into ancient tolerances fascinating, make sure to hit that subscribe button. And for another look at impossible ancient engineering, check out our deep dive on the Great Pyramids air shafts right here. I'll see you in the next one.
What if ancient builders in the Americas moved stones weighing over 100 tons with precision so perfect a knife blade won't fit between them? These megalithic sites defy everything we know about engineering, tools, and logistics. From the Andes to Mesoamerica, they challenge our timeline of human capability. I'm counting down the top 10, and number 1 will make any architect question history. Stick with me.
Hey everyone, welcome back to Curiosity Lab, exploring a fast-changing world. As a retired commercial architect with over 35 years designing and delivering large-scale modular and panelized projects, I've spent my career thinking about how we move, fit, and stabilize massive structures, but nothing prepared me for these American megalithic sites. Today we're ranking the top 10 that still puzzle experts, focusing on the engineering mysteries, precision stonework, and what they imply about ancient knowledge. Let's start the countdown at number 10.
At number 10, Carl Supe in Peru, dating back to around 2600 BCE. This is one of the oldest known urban centers in the Americas, with massive pyramid-like platform mounds built without pottery or advanced metal tools. As an architect, the organizational scale to coordinate labor, quarrying, and construction this early is remarkable. It shows sophisticated planning and resource management long before many civilizations we study. These structures weren't just mounds. They formed the heart of a complex society driven by trade and innovation. Number 9 brings us to Chavin de Huantar in Peru, around 900 to 200 BCE. Famous for its monumental stone architecture and the enigmatic Lanzon monolith, a towering carved stone figure deep inside the temple complex. The intricate underground galleries and precisely placed megaliths suggest advanced ceremonial engineering and acoustic design. From my building background, integrating such large stones into a multi-level temple while managing water and ritual flow demonstrates impressive technical foresight. At number 8, Mitla in Oaxaca, Mexico, known for its stunning geometric stone mosaics and fretwork panels made from thousands of precisely cut and fitted stones. These repeating patterns cover entire walls without mortar in many sections. The craftsmanship here required incredible standardization and patience. As an architect, it's a masterclass in modular design and decorative structural integration that feels almost modern in its precision and aesthetic control.
Already seeing patterns, early complexity, precise stone fitting, and ambitious scale across cultures. These aren't primitive, they're sophisticated responses to their environments and beliefs. What surprises you most so far? Drop it in the comments.
Number 7 is Ollantaytambo in Peru, a formidable Inca fortress and temple complex with enormous rose-colored megaliths transported from quarries miles away and up steep terrain. Some stones are fitted with such precision they form seamless walls resistant to seismic activity. The engineering, logistics, moving and positioning these monoliths without wheels or heavy machinery would test even today's crews with cranes and trucks. It highlights Inca mastery of topography and stone. At number 6, San Agustin Archaeological Park in Colombia. It boasts one of the largest collections of pre-Columbian megalithic statues in South America, over 600 carved volcanic stone figures, some nearly 20 feet tall, depicting warriors, animals, and supernatural beings. These monumental sculptures guarded burial mounds and sacred spaces. The scale and artistic detail required advanced quarrying, transport, and carving techniques that continue to intrigue researchers. Number 5 takes us to the Great Pyramid of Cholula in Mexico. This massive structure, built over centuries starting around 300 BCE, is the largest pyramid by volume in the entire Americas, larger at its base than Egypt's Great Pyramid. Layers upon layers show evolving construction techniques. As an architect, its sheer endurance and the community effort to expand it over generations speak to remarkable long-term planning and civic engineering. At number 4, the Pyramid of the Sun at Teotihuacan, Mexico, one of the largest structures in the ancient world, aligned with incredible precision along the Avenue of the Dead and astronomical events. Built around 100 BCE to 250 CE, its base and volume are staggering. The unknown builders achieved urban planning and monumental construction on a scale that rivaled later empires. From an architect's view, the geometric harmony and labor organization here are truly awe-inspiring.
These middle entries highlight something key from my experience. It's not just about moving big stones. It's about planning, standardization, and tolerances that hold up over centuries. The patterns across distant cultures are fascinating. Which site are you most curious about?
Number 3 is Sacsayhuaman near Cusco, Peru. These iconic zigzag terrace walls feature enormous polygonal stones, some weighing 100 to nearly 200 tons, interlocking without mortar. Joints are so tight, a sheet of paper or even a hair won't fit between them. The irregular shapes fit perfectly, and the inward lean provides earthquake resistance that has survived centuries. As a commercial architect, this dry stone masonry and seismic design rival modern engineering. How they quarried, transported, and precisely placed these giants remains a profound mystery. Coming in at number 2, Tiwanaku and the Acapana platform in Bolivia. These monumental stone structures include precisely cut gateways and platforms with sophisticated drainage systems adapted to high altitude conditions. The scale of the megalithic work and astronomical alignments point to advanced knowledge. The precision in fitting large andesite and sandstone blocks set the foundation for even more remarkable engineering nearby. It showcases a civilization that mastered both grand vision and technical execution. And the number 1 megalithic site in the Americas, Puma Punku, part of the Tiwanaku complex in Bolivia. Here we find massive andesite blocks, one over 130 tons, cut with extraordinary precision, razor-sharp 90-degree internal angles, H-shaped modular forms, grooves, and T-shaped sockets for poured metal cramps. Joints are incredibly tight, surfaces planar, and many blocks appear prefabricated and interchangeable. From my 35 years as an architect, the tolerances, modularity, and craftsmanship suggest techniques and organization that challenge what we thought possible with available tools. This is engineering that still defies easy explanation.
There you have it. The top 10 megalithic sites in the Americas that still defy easy explanation. From foundational complexity to mind-bending precision at Puma Punku, these sites show ancient builders were masters of stone, logistics, and design. Which one surprised you the most? Tell me in the comments. I read everyone. If you love these deep dives into ancient engineering and mysteries, hit subscribe and the bell for more Curiosity Lab episodes. Next time, we're going even deeper, exploring another ancient mystery. Thanks for joining me on this journey. I'm David J. Architect. Stay curious.
"85 meters below the dusty plains of Cappadocia, Turkey, sits a hidden metropolis carved straight into solid rock, 18 levels deep, engineered to hold 20,000 people, complete with fresh air, water, livestock, and wine presses. This isn't a simple cave system, it's Derinkuyu, a fully functional subterranean fortress built without modern steel, computers, or heavy machinery. Who built this underground megacity? How did they pull off such a structural marvel? And what were they running from? Let's look at the blueprint.
Hey everyone, welcome back. As an architect, when I look at a structure, I'm not just looking at the walls, I'm looking at the engineering logic. I'm thinking about structural loads, ventilation, access control, and material science. When you look at Derinkuyu, you aren't looking at primitive survival digs, you are looking at a masterclass in underground civil engineering. Carving down nearly 300 feet into volcanic stone without causing a catastrophic structural collapse requires an incredible understanding of geology. Today, we're doing a deep dive into the construction, the genius layout, and the lingering mysteries behind Turkey's greatest underground city.
The secret to Derinkuyu lies in the unique geology of central Turkey. Millions of years ago, volcanic eruptions blanket the region in thick layers of ash, which compacted into a soft rock called ignimbrite, or volcanic tuff. Tuff is a dream for stonecutters. When freshly carved underground, it's soft enough to yield easily to simple copper or iron hand tools. But once the newly exposed surface comes into contact with air, the stone hardens, creating a durable structural shell. Ancient builders exploited this chemical reaction to excavate hundreds of thousands of tons of rock without modern machinery. Digging 18 stories into the earth creates staggering overburden pressure from the thousands of tons of rock resting above. Without concrete beams or steel rebar, how did it not collapse? The answer is load distribution. The builders left massive monolithic pillars of uncarved rock precisely positioned on every level to carry the dead weight of the ceiling down to the floor below. They excavated arched ceilings and rounded vault corridors to redistribute downward forces laterally, ensuring that despite thousands of years of seismic activity in Anatolia, zero major structural cave-ins have occurred. Pumping breathable air to 20,000 people 85 meters underground is a severe mechanical challenge. Derinkuyu solves this using over 15,000 small air vents tied into 55-meter central ventilation shafts. The system works on passive thermal convection. By utilizing temperature differences between the surface and the stable subterranean air, which stays around 55 degrees Fahrenheit year-round, air is naturally drawn down through the central shaft and pulled through small lateral vents into individual living quarters. The layout ensured every single room received fresh oxygen without creating dangerous drafts.
Think about that for a second. Today, when we design subterranean structures like subways or deep basements, we rely on high-powered HVAC fans, structural steel framing, and digital airflow modeling. The ancient miners at Derinkuyu achieved continuous passive ventilation across 18 levels using nothing more than geometry, heat differentials, and chisel work. But keeping 20,000 people breathing was only half the challenge. They also had to organize an entire society underground.
Derinkuyu was not a chaotic maze. It was a zoned municipality. The top two levels housed livestock stables, deliberately kept close to the surface to minimize odor and manure management issues. Beneath the stables were food production zones containing olive oil presses, wineries, and massive dry storage cellars. Deep in the middle levels sat living quarters, communal dining halls, and a spacious vaulted religious school. The lowest levels housed high-security armories, water cisterns, and a large cruciform church. Everything was logically stacked to support long-term urban habitation during extended surface sieges. The city's architecture was completely optimized for defensive warfare. Passageways were deliberately built narrow and low, forcing invading soldiers to bend over and advance single file. At strategic choke points, builders installed massive 500-kilogram rolling stone disc doors. These giant circular doors could only be sealed from the inside using wooden levers. A small hole in the center of each disc allowed defenders to thrust spears at trapped invaders while remaining completely shielded behind solid rock, making every single level an impenetrable, isolated bunker. If an invading army couldn't breach the stone doors, their next strategy would be to poison the city's water supply. The engineers of Derinkuyu anticipated this biological threat. The central ventilation shafts doubled as deep water wells extending into local aquifers, but the access points were engineered with asymmetric security. The wells could not be accessed or viewed from the surface level. The water could only be drawn up from within the lower, subterranean levels of the city, ensuring surface invaders had no physical way to locate, contaminate, or cut off the city's fresh drinking supply. Derinkuyu wasn't an isolated anomaly. It was part of a larger regional network. Archaeologists have uncovered nearly 200 underground settlements across Cappadocia, but Derinkuyu features something truly extraordinary: a continuous subterranean highway. Carved deep into the rock, an 8-kilometer-long tunnel connects Derinkuyu directly to its sister city, Kaimakla. This tunnel allowed entire populations, trade supplies, and military forces to move safely between two massive underground hubs without ever stepping foot on the surface or exposing themselves to hostile forces patrolling overhead.
Here is where the real mystery kicks in. We can analyze the structural columns, map out the ventilation, and marvel at the defensive choke points all day. But when you ask archaeologists who actually carved out this massive complex and when they did it, the answers get complicated. Because you can't carbon date carved stone, you can only date the organic trash left behind by the people who lived inside.
Mainstream archaeology presents two primary candidates for the original builders. Some scholars attribute the initial upper layers to the Bronze Age Hittites around 1200 BCE, who needed emergency refuges during the chaotic Bronze Age collapse. However, many historians point to the Phrygians of the 8th century BCE as the true architects. The Phrygians were renowned Iron Age stonecutters. Greek historian Xenophon documented these subterranean Anatolian dwellings in 400 BCE, describing complex underground homes housing entire families, domestic animals, and vast agricultural stores carved directly out of the tuff. Regardless of who struck the first pickaxe, Derinkuyu reached its maximum size during the Byzantine era between the 6th and 10th centuries CE. During the intense Arab-Byzantine Wars, early Christian populations expanded the simple Phrygian storage caves into a massive 18-level fortress city. They carved out chapels, Greek inscriptions, and complex security gates to hide from raiding armies for months at a time. To invaders above, the region looked completely deserted, while 20,000 citizens were living, praying, and working quietly right beneath their boots. Alternative researchers suggest Derinkuyu may be far older, proposing it was built as an ancient doomsday bunker against extreme post-Ice Age climate shifts or cosmic bombardments during the Younger Dryas. While mainstream evidence favors the Hittite and Phrygian models, the mystery remains vibrant because less than half of the city has been excavated. What makes it even more wild is how modern humanity rediscovered it. In 1963, a local resident in Turkey knocked down a wall in his basement while renovating, accidentally revealing a secret passage into this thousands of years old, lost subterranean world.
Derinkuyu stands as an absolute triumph of human engineering, proving that when survival is on the line, architecture isn't just about building up into the sky. Sometimes it's about digging deep into the earth. If you enjoyed this architectural deep dive into ancient engineering, hit that like button and subscribe. Let me know in the comments below. Do you think Derinkuyu was built primarily as a military defense hub? Or is there a piece of its origin story we haven't uncovered yet? Thanks for watching, and I'll see you in the next one.
"5,000 years ago, before the first stone was laid at Stonehenge or the Great Pyramid of Giza was finished, a civilization in the Peruvian desert was already building a metropolis. They engineered cities without warfare, skyscrapers out of mud, and foundations that could dance with earthquakes. Today, we're decoding the architectural evolution from the sacred city of Caral to the blood-stained pyramids of the Moche.
I'm an architect, and when I look at ancient Peru, I don't see primitive ruins. I see a masterclass in resilient engineering. Between 3000 BCE and 800 CE, these builders solved the same problems we face today: seismic stability, hydraulic management, and massive labor logistics. We're going beyond the Inca label to explore the 4,000-year evolution of the Waka. From the invention of the shicra to the 140 million brick mystery of the Moche, let's dive into the top 10 engineering secrets of ancient Peru.
Caral isn't just a site, it's the oldest city in the Americas. Spread over 626 hectares, it represents a moment where humanity invented government and urbanism independently. As an architect, the urban planning here is striking, split into an upper and lower sector to reflect a dualistic worldview. This wasn't a random settlement. It was a zoned metropolis where elites lived atop pyramids while artisans and farmers supported a trade-based economy that stretched from the coast to the Amazon. In almost every other cradle of civilization, pottery came before pyramids. But Caral is a technological anomaly. They built massive, monumental complexes without a single ceramic pot for cooking or storage. Instead, they focused their R&D on textiles and fiber technology. They utilized quipus, knotted string recording systems, millennia before the Inca, proving that you don't need clay pots or a written alphabet to manage a complex multi-valley bureaucracy. Living in the Pacific subduction zone, Caral's architects faced a constant threat: megathrust earthquakes. Their solution was the shicra, woven reed bags filled with angular stones. These weren't just filler, they were a prehistoric form of base isolation. During an earthquake, the stones roll and shift within the bags, dissipating kinetic energy and preventing the brittle stone facades from exploding outward. It is an elegant, low-cost engineering hack that modern structural engineers are studying to protect rural villages today.
Think about this. Excavations at Caral have found 0 defensive walls and 0 weapons. As an architect, that changes the site plan entirely. This wasn't a fortress, it was a cooperative trade hub. They used music and shared ideology to coordinate labor instead of military force. The project management was driven by reciprocity, creating a blueprint for peaceful urban growth.
To build a city in a desert that gets only centimeters of rain, you must master the groundwater. Caral's engineers developed amunas, Sierra runoff capture systems that replenished the valley's aquifer. They surveyed a ramped aqueduct canal that stretched for kilometers with a precise, low declination angle to bring water from the Supe River directly into the city precincts. This hydraulic infrastructure allowed for multi-cropping and the production of industrial-scale cotton for fishing nets, the true currency of the Norte Chico. As we transition from Caral to the Moche, the building material shifts from stone to standardized adobe mud bricks. Architects can track cultural evolution through brick morphology. It started with hand-formed conical bricks in the formative period, but by the time the Moche took over, they had mastered cane molds for mass production. These bricks were a specific mix: 30 to 70% clay for cohesion, sand for stability, and organic binders like straw or animal dung to control shrinkage during the 14-day sun-drying process. On the top of millions of Moche bricks, we find maker's marks, symbols like dots, lines, and even human handprints. These weren't decorative, they were industrial receipts. they identify over 100 different communities that contributed labor as a form of tax tribute, a direct precursor to the Inca Mita system. By building in segmented columns, the architects could have different groups working on their own sections simultaneously, ensuring accountability and structural speed in a massive public works project. If you want to see absolute scale, look at Huaca del Sol. It was once the largest adobe structure in the Americas, composed of a staggering 140 million bricks. Standing over 50 meters high, it functioned as the administrative and royal heart of the Moche world. Tragically, we only see a shadow of it today. In the 17th century, Spanish looters diverted the entire Moche River to wash away 2/3 of the pyramid just to reach the gold buried within.
As an architect, the Meta system is the ultimate war. Key force management tool. This wasn't slavery, it was a social contract. The state provided food, housing, and maize beer from state storehouses, and in return, you gave your turn of seasonal labor. This reciprocal engine is what allowed a civilization without money to build massive complexes like Huaca del Sol and eventually Machu Picchu.
While Sol was for the living, Huaca de la Luna was for the gods. This temple was built like a layer cake. Every century, the Moche would bury the old temple to build a new one directly on top, preserving the vibrant murals below. These walls depict the Decapitator deity, a terrifying, fanged figure associated with human sacrifice. Evidence of these rituals, the remains of over 40 men found in sediment layers, suggests they were desperate bids to appease the gods and stop the destructive rains of El Niño. In 2006, the discovery of the Lady of Cow shattered the myth of male-only Moche rule. This elite woman was found at Huaca Cao Viejo, wrapped in a 100-kilogram funerary bundle and covered in intricate tattoos of spiders and serpents. Buried with gold crowns and ceremonial clubs, she was likely a priestess queen with shamanic powers. Her diet, rich in maize and seafood, confirmed her status as a high-ranking local, proving that female authority was deeply embedded in the social architecture of the Moche. How do these giants fall? For Corral and the Moche, the architect's greatest enemy wasn't war, but climate change. Successive El Niño (ENCO) events caused catastrophic flooding that washed away fertile topsoil and triggered Aeolian sand incursions. These dunes physically swallowed agricultural land and blocked irrigation canals. As the marine resource base collapsed and the desert reclaimed the fields, the social contract of the Mita failed, leading to the abandonment of the Great Pyramids around 800 CE.
The pyramids of Peru are a testament to what happens when ingenuity meets a hostile environment. From Corral's seismic shicras to the Mochi's industrial-scale adobe, these ancient architects built the blueprint for sustainable survival in the desert. If you found this deep dive into ancient tolerances and hydraulic engineering fascinating, make sure to hit that subscribe button. And for another look at impossible ancient logistics, check out our deep dive on the Terracotta Army right here. I'll see you in the next one.
Imagine carrying a 600-pound log for 50 miles across a scorching desert. Now, imagine doing it 200,000 times. No wheels, no draft animals, no local forests. This is the engineering mystery of Chaco Canyon. From massive stone cities planned centuries in advance to walls that track the moon's 18-year cycle, The ancestral Puebloans weren't just builders, they were master architects. Today, we're diving into the impossible engineering of the Anasazi through the architect's lens. How did they build it? And what do these footprints of the past tell us? Most ancient cities grow organically, room by room, but the great houses of Chaco Canyon were different. Take Pueblo Bonito, a massive complex with over 600 rooms reaching 5 stories in height. From an architect's perspective, the level of precision is stunning. Unlike organic settlements, these structures were pre-planned. Builders determined the final scale long before construction began. Recent surveys reveal that the site's dimensions align almost perfectly with a golden rectangle. This represents a centralized vision of social organization and geometry achieved without a written language or formal number system. To support 5 stories of vertical weight without modern steel, builders utilized a sophisticated core and veneer masonry technique. The wall's center, the core, consisted of rough stones and mud mortar, while the exterior veneer was finished with meticulously shaped, thin slabs of sandstone. Architects designed these load-bearing walls to be several feet thick at the base to bear the immense downward pressure of the floors above. This wide footprint provided structural stability and thermal mass, creating a durable, seismic-resistant environment that has survived for nearly a millennium in the harsh San Juan Basin climate. The true scale of ancestral Puebloan logistics is found in their roofs. Over 200,000 timber beams were used in Chaco Canyon alone. The nearest stands of suitable ponderosa pine, spruce, and fir were in the Chusca and San Mateo Mountains, over 50 to 70 miles away. Isotope analysis confirms these logs were transported from these high elevation ranges. Each log was roughly 15 feet long and weighed up to 600 pounds. Since the logs show no evidence of dragging or rolling, engineers believe crews carried them by hand across the open desert, a staggering investment of human labor.
As an architect, what strikes me most here is the shift from survival to sophistication. We often view ancient builders through a primitive lens, but the transition from simple pit houses to these massive, pre-planned stone complexes requires a level of social cohesion and centralized command that rivals modern construction management. It wasn't enough to just build a wall. They were building a physical manifestation of their social order. Now, let's look at the mathematical and celestial blueprint that guided their hands.
Precision is the hallmark of advanced engineering, and the Sun Temple at Mesa Verde is a masterclass in ancient geometry. Surveys reveal that the site wasn't built by eye, but followed a rigorous mathematical plan. Builders employed golden rectangles and Pythagorean 3 to 4 to 5 triangles with remarkable accuracy. Most fascinating is the identification of a standard unit of measurement, roughly 30.5 centimeters, or 1 foot, used to lay out key features. This quantitative evidence suggests a shared architectural language passed down through generations, achieved entirely without a written numbering system. The Great Kiva represents a peak in structural span engineering. These massive subterranean chambers, like Casa Rinconada, reached nearly 20 meters in diameter. To roof such a vast void, architects used 4 enormous timber pillars, or stone pilasters, to support a complex, cribbed log roof structure. From my lens, the load-bearing requirements for these roofs were immense. Beyond the physics, the architecture is symbolic. Casa Rinconada features 28 wall niches, precisely matching the days of the lunar month. It is a fusion of structural tolerance and celestial timekeeping. Perhaps the most iconic Puebloan feature is the T-shaped door. First appearing around 1020 AD at Chaco Canyon, these notched portals expanded across the southwest. As an architect, I look at these as restricted access points or social markers visible from a distance. Indigenous perspectives, like those from the Hopi, view these doors as itakuku, footprints of the past, marking the spiritual migrations of clans across the landscape. Interestingly, many were later sealed with masonry, suggesting a radical shift in the room's function or the community's social privacy. Ancient architects didn't just observe the sun, they mastered the complex 18.6-year lunar standstill cycle. This isn't an easy task. It requires recording the moon's shifting horizon positions over nearly 2 decades. Yet, great houses and high-altitude shrines are precisely aligned to the moon's maximum extremes, often at a minus 53.5 degree azimuth. The precision is stunning, often within 1 degree, a tolerance difficult to achieve without modern compasses. By integrating these alignments into their walls, they anchored their monumental cities to the repeating rhythms of the heavens.
As an architect, what's truly profound here is that the ancestral Puebloans weren't just solving physical problems like shelter, they were mapping their spiritual geography onto the desert floor. These stone structures weren't just buildings, they were itakuku, or footprints, permanent markers of their migration and their contract with the land. It's a reminder that great design doesn't just house people. It anchors a society to its history and the cosmos. Now, let's look at their final, most massive environmental and spiritual achievements.
Precision reached its peak with the Great North Road, a 50-kilometer engineered ceremonial route. While modern roads connect trade hubs, this road terminated abruptly at the edge of Cuts Canyon, a symbolic link to the ancestral underworld. From a surveyor's perspective, the accuracy is staggering. One 16-kilometer segment maintains a bearing within 0.5 degrees of true north. This wasn't built for wheels or commerce. It was a physical manifestation of a science of time, proving that Chacoan infrastructure was as much about spiritual alignment as it was about logistics. Long before green building, these architects mastered passive solar design. Most great houses utilized south or southeast-facing entrances to capture the low winter sun for warmth while providing vital shade during scorching summers. Architects designed massive, thick walls of stone and adobe to act as thermal mass, regulating interior temperatures between freezing nights and hot days. Joined back walls served as windbreaks against harsh canyon gusts. Every choice, from the building's orientation to its wall thickness, was a calculated engineering response to the unforgiving San Juan Basin climate. To truly understand this architecture, we must see it through an indigenous lens. Houses as living beings. For descendants like the Hopi, a home is a nurturing entity, not a static object. Features like T-shaped doors and great kivas are cultural metaphors, itakuku, or footprints, left across the landscape to mark the spiritual journeys of ancient clans. Their architecture fulfilled a sacred contract to be stewards of the earth. These cities represent a center place, where heaven and earth are integrated through geometry, ritual, and a legacy that has endured for 1,000 years.
From the staggering logistics of transporting 200,000 timbers to the geometric perfection of the Sun Temple, the architecture of the ancestral Puebloans is a masterclass in ancient engineering. They didn't have steel, computers, or written numbers, yet they built a society with a sophisticated understanding of math, astronomy, and environmental design that we are still decoding today. These cities weren't simply abandoned. They were part of a continuous migration that lives on in the Pueblo people today. If you enjoyed this look at ancient engineering through the architect's lens, hit the like button and subscribe. In our next video, we're heading to the high-altitude alcoves of Mesa Verde, to explore the defensive secrets of the cliff dwellings. What engineering mysteries do those sheer canyon walls still hide? You won't want to miss it. I'm David J. Architect, and thanks for watching.
We've seen the massive stone cities of Chaco, but the ancestral Puebloans had an even greater engineering challenge waiting in the clouds. Imagine building a high-rise apartment complex into the face of a sheer 90-foot limestone cliff. No cranes, no safety harnesses, just gravity-defying masonry and an incredible understanding of structural physics. Today, we're looking at the top 10 architectural wonders of the cliff dwellers. From the urban planning of Cliff Palace to the geometric math of the Sun Temple, we're decoding how these ancient architects turned hostile canyon walls into masterpieces of passive solar design and defense.
Hi, I'm David J. As an architect, I've always been fascinated by how we adapt structures to the most unforgiving environments. In our last deep dive, we explored the logistics of Chaco Canyon's timber transport. But today, we're heading up. We're exploring the ancestral Puebloan cliff dwellings, not just as ruins, but as sophisticated vertical cities. We'll examine the geotechnical engineering used to stabilize alcoves, the quantitative math behind their temples, and the living building philosophy that descendants say makes these structures footprints of the past. Let's go.
Cliff Palace in Mesa Verde is the peak of ancestral Puebloan urban planning. Built into a massive sandstone alcove, it contains over 150 rooms and 23 kivas. From an architect's lens, the site is a masterclass in spatial management. Builders had to manage the limited floor space of the alcove by building vertically, often reaching 4 stories. They utilized the natural rock ceiling as a structural shield, protecting the masonry from water erosion. This created a dense, communal environment where every square inch of stone was calculated to support the weight of the city above. In the Verde Valley, Montezuma Castle stands as a 5-story high-rise built directly into a limestone cliff. This wasn't a castle, but a sophisticated apartment complex for 35 to 50 people. As an engineer, the logistics here are staggering. Builders had to haul thousands of pounds of limestone and mud mortar up nearly 90 feet using only ladders and ropes. They anchored the walls into natural recesses, using the cliff's own geology as a foundation. This verticality provided ultimate defense and thermal mass, keeping the interior cool in Arizona's 100-degree heat. At Spruce Tree House, architectural research reveals a sophisticated evolution in mortar technology. Analysis shows that early builders used a mix of mesa-top red loess and sandy soil. However, as construction progressed, they shifted to using crudely crushed blue-gray shales. This wasn't random. The shale provided a superior chemical bond and reduced shrinkage as the mortar dried in the arid climate. This material science allowed them to build walls that have survived 800 years of seismic activity and natural weathering before modern stabilization efforts were even required.
What we're seeing here is a radical shift in construction management. They weren't just building houses anymore, they were engaging in geotechnical engineering. At Spruce Tree House, the National Park Service is currently using 20-foot-long tensioned rock bolts in a reticulated pattern to keep the alcove arch from collapsing. Thoughtful. It's a reminder that these ancient architects were working with a living, moving landscape. They understood that the cliff itself was their primary structural member. Now, let's look at the mathematics they used to orient these buildings toward the stars.
Mesa Verde's Sun Temple provides the most compelling evidence of ancient quantitative math. Recent surveys show the site was laid out using a standard unit of measurement, the Puebloan foot, measuring exactly 30.5 centimeters. The D-shaped structure wasn't built by eye. It follows the precision of golden rectangles and Pythagorean 3 to 4 to 5 triangles. Builders used chords and straight edges to achieve a level of geometric accuracy that rivals modern surveying. This proves that ancestral Puebloans possessed a sophisticated, shared architectural language, even without a written numbering system. Betataken, meaning house built on a ledge, is perfectly positioned within a massive Navajo sandstone alcove. Its orientation is a masterstroke of passive solar engineering. The alcove's deep roof blocks the high, harsh summer sun, keeping the rooms in shade, while the low winter sun reaches deep into the complex to provide natural heating. Architects also utilized the alcove's parabolic shape for acoustic communication. This site wasn't just a shelter, it was a calibrated thermal battery designed to balance the extreme temperature swings of the high desert. Quetzal remains one of the best preserved sites, featuring iconic T-shaped doors that have puzzled architects for centuries. Indigenous descendants, like the Hopi, call these doors itakuku, footprints of the past. As an architect, I see these not just as portals, but as cultural signals. Many T-doors at Quetzal were later sealed with masonry, suggesting a shift in social identity or a need for privacy as the community migrated. These footprints served as tangible monuments of their spiritual contract to be stewards of the earth. Ancient architects at Mesa Verde mastered the complex 18.6-year lunar standstill cycle. By aligning the painted tower area of Cliff Palace with the Sun Temple across the canyon, they could track the moon's southern maximum moonset with incredible precision. This required recording data over decades, well beyond the lifespan of a single construction project. Integrating these alignments into their walls turned their cities into monumental timepieces. It's an engineering feat that proves they weren't just observing the heavens, they were writing the cosmos into their architecture.
This is what I call the science of time. To build a city that tracks an 18-year cycle requires a level of intergenerational data management that we usually only associate with modern observatories. For the Pueblo people, these buildings are living beings that nurture families and fulfill a sacred contract. As we look at the final chapters, remember that these aren't abandoned ruins. They are the permanent records of a culture that is still very much alive and migrating today.
At Walnut Canyon, builders utilized narrow limestone ledges on a steep-walled canyon known as the Island in the Sky. From a structural lens, the tolerances were razor-thin. Rooms were built with back walls flush against the cliff and front walls perched on the very edge of the precipice. This positioning was intentionally defensive, controlling access to vital water sources below. The logistics of building here meant every stone and gallon of water had to be carried down into the canyon, showcasing a community willing to trade convenience for ultimate security. White House Ruin in Canyon de Chelly is unique because it spans two levels, a structure on the canyon floor and one in a high-altitude alcove above. Architects designed these as a single integrated unit, likely connected by long ladders or toe holds cut into the red sandstone. This dual-level design served both as a storage facility and a defensive retreat. The masonry style here mimics Chacoan core and veneer, proving that even in these remote canyons, the architectural DNA of the great houses was being adapted to the vertical cliff environment. In ancestral Puebloan architecture, a house was never truly finished. Analysis of kiva walls at Ruin 12 reveals multiple layers of plaster, sometimes up to 5 elementally distinct applications. Ethnographic data suggests that replastering was a communal ritual, often performed by young women before seasonal ceremonies like the buffalo dance. These layers aren't just maintenance, they are a stratigraphic record of the community's life. Each application added a new skin to the living building, reinforcing the walls with calcium-rich mortars that acted as an additional structural veneer.
From the staggering 90-foot heights of Montezuma Castle to the 30.5-centimeter Puebloan foot used to lay out the Sun Temple, the cliff dwellers were masters of vertical engineering. They didn't just survive on the edge, they built a science of time into the stone itself. These structures weren't abandoned in a hurry, they were part of a continuous migration, a legacy of footprints that still guides the Pueblo people today. If you enjoyed this second look at ancient engineering through the architect's lens, hit the like button and subscribe. We're heading south for our next deep dive to the borderlands, to explore the massive adobe labyrinths of Paquime, Casas Grandes. What engineering secrets are hidden in those sun-dried walls? You won't want to miss it. I'm David J. Architect, and thanks for watching.
Welcome back to the Curiosity Lab. As an architect, I'm obsessed with tolerances and logistics. But the ancient builders of Petra, Ellora, and Lalibela didn't have steel, cranes, or blueprints. They worked with solid bedrock, employing a brutal top-down extraction method where failure meant starting over. We are counting down the top 10 rock-cut and cave architecture wonders, focusing on the sheer difficulty and the brilliant theories behind how they actually pulled this off.
Welcome back to the Curiosity Lab. As an architect, I'm obsessed with tolerances and logistics. But the ancient builders of Petra, Ellora, and Lalibela didn't have steel, cranes, or blueprints. They worked with solid bedrock, employing a brutal top-down extraction method where failure meant starting over. We are counting down the top 10 rock-cut and cave architecture wonders, focusing on the sheer difficulty and the brilliant theories behind how they actually pulled this off.
At number 10, the Ajanta Caves in India, carved into a horseshoe cliff of hard basalt. The logistical nightmare here was carving inward without scaffolding. Their brilliant solution? A technique where wooden wedges were hammered into drilled holes, then soaked with hot water. The expanding wood fractured the rock perfectly. They literally used water and wood to split a mountain, laying the groundwork for some of the earliest continuous rock-cut spaces. Number 9 takes us to the fairy chimneys of Cappadocia. From an engineering standpoint, this terrain is a dream. Fine-grained, compressed volcanic ash. The material's softness allowed locals to carve elegant, multi-level homes directly into the cones. But the real genius is thermal regulation. The porous rock acts as natural insulation, creating a sustainable, energy-efficient habitat long before modern HVAC systems existed. It's nature and architecture working in perfect harmony. At number 8, we plunge deeper into Cappadocia to Derinkuyu. This wasn't just a shelter, it was an underground metropolis for 20,000 people. The architectural difficulty here was defense and crowd control. Planners designed 2-foot-wide bottleneck entry tunnels to force attackers into single-file, hunched positions. Below ground, strict zoning rules mapped surface neighborhoods to specific subterranean levels. It is a masterclass in ancient urban planning and siege survival.
Notice how these early sites beautifully adapted to the rock's natural weaknesses? But what happens when the scale becomes massive and the rock gets significantly harder? The margin of error practically vanishes.
Number 7 is the Longyu Caves in China, an absolute architectural anomaly and an unsolved archaeological wonder. Discovered completely submerged, these massive artificial caverns push the boundaries of known ancient excavation techniques. The walls and pillars feature perfectly uniform, parallel chisel marks. How did they achieve such structural precision and stability over massive spans without modern surveying equipment? It remains a profound mystery that continues to baffle modern structural engineers. At number 6, we look at the geological mastery of the Nabateans in Petra. Carving a tomb on Mount Al-Mu'izra, architects encountered 2 horizontal geological fault lines. Instead of abandoning the site, they adapted. They engineered the columns to stop exactly at the second fault line, perfectly integrating the mountain's cracks into the architectural design. This flexible design process prevented structural failure and ensured the tomb's durability through millennia of seismic activity. Number 5 brings us to the rock-hewn churches of Lalibela, carved from scoriaceous basalt. King Lalibela's craftsmen employed a radical construction strategy to build a new Jerusalem. To minimize scaffolding, they carved the churches completely top-down. By utilizing perimeter trenching, they isolated a solid block from the plateau, instantly defining a roof at ground level. From there, descending ramps allowed workers and waste rock to move safely in and out. Staying in Lalibela for number 4, we examined their brilliant water management. Heavy rains could easily flood these sunken pits. The architects designed catch pits and scuppers directly into the monolithic bedrock. Because the masonry and drainage were carved from the exact same monolith, there were no cold seams or mortar joints for water to exploit. Leaks were virtually impossible. It's an incredibly elegant solution, combining structural engineering and fluid dynamics.
Lalibela shows us the absolute power of monolithic carving, but our top 3 take this unforgiving technique to a terrifying scale. If an ancient worker chiseled an inch too deep, an entire facade was permanently destroyed. Let's look at the ultimate stone masterpieces.
At number 3 is Petra's crown jewel, Al-Khazneh. Carving this monumental facade straight out of the cliff required an unbelievable sequence. Workers first dug horizontal tunnels into the rock face to establish a foothold, followed by vertical trenches. They chiseled centimeter by centimeter, top to bottom. With clean, straight classical lines, any broken piece of cornice or capital was completely irreparable. The resulting structural tolerances achieved with basic hand tools are simply staggering. Number 2 brings us to the Ellora Caves and the sprawling Kailasa Temple complex. The Nandi Mandapa alone is a towering 29.3 meters high, standing on 16 intricately carved pillars. The difficulty of ensuring rockfall safety while hollowing out massive pavilions from a basalt cliff is immense. Every load-bearing column had to be perfectly aligned as they dug downwards, requiring preconceived 3D spatial awareness that rivals modern computer-aided design software. Taking the number 1 spot is the main Kailasa Temple itself, the world's largest monolithic structure. Excavators removed an estimated 200,000 tons of solid basalt rock to isolate this freestanding temple. Like carving a perfect sculpture inside a deep hole, vertical extraction made removing debris incredibly challenging. Every intricate panel and flying bridge was pre-planned before the first strike. It stands as the absolute pinnacle of human architectural ambition.
From the bottleneck tunnels of Cappadocia to the monolithic peaks of Ellora, these sites prove that ancient builders possessed a mastery of geology and 3D spatial planning that we are only just beginning to truly appreciate. When your building material is a mountain, you don't get a second draft. Which of these rock-cut wonders blew your mind the most? Let me know in the comments. Make sure to hit subscribe because next week we're jumping into the bizarre structural secrets of ancient aqueducts.
See you in the lab!
Hey, so I spend a lot of time thinking about how things are built. It's kind of the job. And I'll be honest, most of what I know about construction makes me look at these places and just short circuit. We're talking about civilizations with no steel, no GPS, no cranes, no calculus textbooks. And they were pulling off feats that our best engineers today would look at and go, I mean, yeah, I guess that works. We're going to cover a lot of ground today, literally. 3 video segments, 3 types of impossible. Impossible precision, underground extremes, and cosmic scale. I'll give you the facts. I'll give you the theories, the sensible ones and the wild ones. And then I will leave it up to you to decide.
Sacsayhuaman and Cusco, Peru. In downtown Cusco, you can press your hand against walls that are over 500 years old, no mortar, no gaps, and feel them still perfectly locked together. Some of these stones have up to 12 edges. 12! Each one fitted precisely against its neighbor. No 2 blocks the same shape. And here's the engineering twist. That's not a flaw in the design. That's the design. When earthquakes hit, and they do, the irregular shapes let the wall move, absorb the energy, then resettle. The Spanish colonists built on top of these foundations because they literally couldn't tear them down. Puma Punku, Bolivia. Puma Punku sits over 12,000 feet above sea level, and the stones here were cut to tolerances of less than 0.1 millimeters. That's tighter than a human hair. The H-shaped blocks interlock like machined parts. No drawings, no written records, no tools found at the site. The Tiwanaku people had no wheels and no steel. So either we're missing something enormous about what they did have, or the answer is genuinely unsolved. Barabur Caves, India. 3rd century BCE, the Mauryan Empire, and someone carved these caves directly into solid granite, then polished the interior walls to a mirror finish. We're talking acoustics that bounce and layer sound like a recording studio. We're talking surfaces that show no wear after 2,300 years. How do you polish granite to that standard with ancient tools? Archaeologists are still working on a satisfying answer. Serapeum of Saqqara, Egypt. Underground in Saqqara, Egypt, there are 24 solid black granite boxes. Each one weighs up to 70 tons. Each lid fits so precisely that no air passes between them. The granite was sourced from Aswan, over 500 miles away. The polish inside is mirror quality, and some researchers report subtle vibrations in the chambers even in complete silence. What were they for? Officially, bull burials, but the level of craft applied to a burial chamber for a bull is, let's say, it raises questions. Longyu Caves, China. In 1992, a farmer in China drained a pond. Underneath it, a cave, then another, then 36 of them, a vast subterranean complex carved entirely by hand. Nobody knows who built them. Nobody knows when. No tools, no human remains, no records. Just 1.3 million cubic yards of removed sandstone and nowhere to put it. And every single chisel mark across every ceiling and every wall? Identical spacing, identical depth, identical angle. That's either the most disciplined workforce in history or something else entirely. You decide. Al-Nasla, Saudi Arabia. In the Tama Desert, there's a sandstone boulder split perfectly in two. Clean, vertical, laser straight. No erosion on the cut surface. No fracture pattern consistent with natural sandstone splitting. And ancient carvings of humans and horses on the face, meaning people noticed this thing thousands of years ago too. Geologists suggest underground forces, but no current model can reliably reproduce that mechanism. So, nature's most precise accident? Or something we haven't figured out yet? Yangshan Quarry, China. The Ming Dynasty wanted a stone for an imperial tomb. They carved it, all 16,000 tons of it, then realized they couldn't move it. The largest block is 240 feet long. For comparison, the largest stone in the Great Pyramid is about 80 tons. This one is 200 times heavier. It still sits where they left it, fully detached from the mountain, never transported, a monument to the moment ancient engineers hit the wall of what was physically possible.
Okay, so as an architect, I want to flag something. Every single site in that first group shares a common problem: joinery. How do you fit irregular shapes together with zero gap tolerance at massive scale without modern tools? My best working theory: these civilizations had techniques we haven't fully reconstructed. Not magic, not aliens, just knowledge that didn't make it into the written record. Because a lot of these cultures didn't really have written records. We lose knowledge all the time. We lost Greek fire, we lost Roman concrete for centuries, so I'm not saying it's impossible. I'm saying we're missing a chapter.
Derinkuyu, Turkey. Derinkuyu is a city, a full city, just underground, 18 levels deep. Homes, stables, wine cellars, churches, schools, water wells, and a ventilation system sophisticated enough to circulate fresh air through the whole complex. It could shelter up to 20,000 people, along with their animals, during sieges and invasions. The walls haven't collapsed, the ventilation still works in principle, and it was carved entirely into soft volcanic rock by hand. Lalibela, Ethiopia. In Ethiopia, King Lalibela built 11 churches, but he didn't build up, he carved down, straight into solid mountain rock, from the top downward. To do that, you have to hold the entire finished structure in your mind before you remove a single block. There's no fixing mistakes. The volume of rock removed is estimated to be equivalent to building a small city. Engineers suggest it should have taken hundreds of years. Historical records say 18. There are no surviving technical documents, just the churches, still in active use today. The Hanging Temple, China. Built into a vertical cliff over 200 feet high. No foundation beneath it. The entire structure rests on wooden beams driven into cracks in the rock, with internal cross-bracing that distributes weight without any external columns. It's been there for 1,500 years. It's survived earthquakes. It doesn't get direct sun or rain. The cliff overhang protects it, which turns out to be the genius of the placement. It's also the only building in China that honors Buddhism, Taoism, and Confucianism in the same space. Architecturally and spiritually, it's threading a needle. Sigiriya, Sri Lanka. A king murders his father. His brother is coming for him. So naturally, he builds a fortress on top of a 600-foot jungle monolith. surrounds the base with water gardens and boulder gardens connected through a still-functioning underground hydraulic system, and commissions frescoes on the rock walls whose colors have survived 1,500 years of tropical climate. The ancient painting technique used for those frescoes still isn't fully understood, and the king eventually came down. The brother won. Fanjingshan, China. 2 temples, twin vertical rock peaks, separated by a 300-foot deep chasm, connected by a bridge suspended in mid-air at over 8,200 feet elevation. To reach them, you climb thousands of steps carved into cliff edges, through clouds that regularly produce the Brocken Spectre, a giant human-shaped shadow cast onto the mist below you. Buddhist pilgrims have been making this climb for centuries, which raises the question, who built the first steps? And why were they so confident the temples at the top were worth it? Chand Baori, India. 3,500 steps, over 100 feet deep, and cooler at the bottom by about 9 degrees, making it a natural air conditioning system in Rajasthan's brutal summers. Chand Baori was built in the 9th century as a water storage solution, a social gathering place, and a spiritual site all in one. The geometry is so precise, so symmetrical, that modern architects study it. Local legend says it was built overnight by spirits, and that if you descend and try to return by the same path, you'll never find your way back. Probably a legend. Probably. Qanat, Persia. 1st millennium BCE. No GPS, no modern surveying equipment, and Persian engineers built underground water tunnels, some stretching dozens of miles, with slopes between 0.1 and 0.5%. That's near-perfect gradient, enough to keep water moving without erosion, not enough to cause flooding. Thousands of years later, many of these systems still deliver water to cities and farmland across the Middle East and Central Asia. The engineering precision required to achieve that without modern tools is, honestly, staggering.
You notice a pattern here. These aren't just engineering achievements, they're site selection achievements. Whether it's a cliff face, a mountaintop, a desert aquifer, or solid bedrock, these builders looked at the absolute hardest place to build and said, that's the place. And then they made it work for centuries. Now I want to be clear. I'm not going to sit here and tell you how they did it, because in a lot of these cases, we genuinely can't really tell. What I will say is that the fact that we don't have the full answer yet doesn't mean the answer is supernatural. It might just mean we haven't asked the right questions yet. Or maybe we have, and we're not ready for the answer.
Göbekli Tepe, Turkey. Everything we thought we knew about the timeline of human civilization, Göbekli Tepe broke it. 12,000 years old. That's 7,000 years before the Egyptian pyramids. Built by hunter-gatherers who, by all previous assumptions, shouldn't have been organizing large-scale construction projects yet. The T-shaped pillars weigh up to 20 tons. The animal carvings are sophisticated, and there's no evidence of daily life at the site. No cooking, no sleeping, no living. It was purely ceremonial, which means before humans figured out farming or cities, we figured out religion and monuments. The Great Pyramid, Egypt. Originally clad in white polished limestone that reflected sunlight across the desert, a beacon visible for miles. Inside, a network of corridors, pressure-relieving chambers, and air shafts demonstrating a working understanding of gravity and structural load that wouldn't be formally theorized for another 4,000 years. Aligned to true north with a deviation of 3/60ths of a degree. and some researchers believe pi and the golden ratio are encoded in its proportions. Not approximately, but precisely. Is that intentional? Is it coincidence? The pyramid isn't talking. Teotihuacan, Mexico. Before the Aztecs called it the City of the Gods, Teotihuacan was one of the largest cities in the ancient Americas, planned along a unified urban axis with precise astronomical alignment. The Pyramid of the Sun and the Pyramid of the Moon correspond to solstices, equinoxes, and key celestial observation points. Inside the Pyramid of the Sun, archaeologists found mica, sourced from Brazil, thousands of miles away, layered throughout the structure with no apparent structural function. Mica is highly reflective. Mica is used in electronics for its insulating properties. What were they doing with it? Nobody knows. Chichen Itza, Mexico. El Castillo has 365 steps, one for each day of the solar year. That's not a coincidence. During the spring and fall equinoxes, sunlight hits the pyramid at an angle that casts a serpent-shaped shadow down the staircase, the god Kukulkan descending. It only works because of precise solar calculations built into the stone geometry. And if you stand at the base and clap, the echo returns sounding nearly identical to the call of the Quetzal bird. Whether that acoustic effect was intentional is debated, but it's there, and it's perfect. Baalbek, Lebanon. 3 stones, each one weighing over 800 tons, placed nearly 23 feet above ground, joined perfectly. These are the trilithon at the Temple of Jupiter, and no other Roman site shows any evidence of lifting stones this heavy. Half a mile away in the quarry, a stone weighing approximately 1,000 tons, still partially buried, and another estimated at 1.6 million pounds, the largest stones ever carved by human hands, never moved. We still don't fully understand how the others got there. Carnac, France. 3,000 standing stones, arranged in perfectly straight parallel rows stretching for miles across uneven terrain. The largest single stone weighs around 350 tons, moved and erected with ropes and wooden levers. The alignments correspond precisely to solstice points and lunar cycles, making Carnac a large-scale astronomical instrument built around 4,500 BCE. That's thousands of years before the Egyptian pyramids. No tools found, no design plans, just the stones, the sky, and the alignment. Petra, Jordan, the Rose City. An entire civilization's architecture carved, not built, sculpted into pink sandstone cliffs in a highly seismic zone where the structures have survived millennia and multiple major earthquakes. Some buildings contain symbols and spatial layouts that remain undeciphered. Whether they encode cosmological beliefs or practical information, we don't know. What we do know, walking through the Sikh Gorge and having the treasury suddenly appear around a corner, is one of the great architectural reveal moments on Earth. Lishan Buddha, China. Carved directly into a cliff, 233 feet tall, equal to a 23-story building. Took 90 years to complete starting in the 8th century. Inside the ears, collar, shoulders, and back, a hidden drainage system that has protected it from rain damage for over 1,200 years. The drainage system is invisible from the outside, which means whoever designed the statue also designed the waterproofing as part of the original plan. The feet alone are large enough to hold dozens of people standing at once. Nan Madol, Micronesia. Built on a coral reef, in the middle of the Pacific, with no local fresh water or food supply. 750,000 metric tons of basalt. columns weighing up to 50 tons, stacked without mortar. Walls rising 50 feet against ocean waves, still standing. It's a floating metropolis of over 100 artificial islands, and everything needed to build and sustain it had to be transported from the mainland. Some of the structures are partially submerged. Nobody's sure if that was always the case. Madain Saleh, Saudi Arabia. 131 tombs carved into towering sandstone formations in the desert, each one a unique, ornate signature for the person buried inside. The Nabateans were the second most powerful trading civilization in the ancient Middle East after Petra, and like Petra, they built by subtracting, carving into stone rather than stacking it. Despite hundreds of carved monuments, almost no evidence of the tools or scaffolding systems used has ever been found. Their techniques may have been so advanced they left no trace, or so simple we keep looking past them. Dujiangyan, China. An irrigation system designed in 256 BCE that has operated continuously for over 2,200 years. No dam, no cement, just stone, bamboo, and hydraulic calculations that split and redirect a major river using natural elevation and flow. It still delivers water to millions of people today, with almost no major repairs. The engineer who designed it, Li Bing, is worshipped as a god in the region. Given the results, that tracks.
So here's where I land on all of this. I don't think these places were built by aliens. I don't think ancient peoples were less intelligent than us. That's actually a bias we need to check ourselves on. What I think is that the human ingenuity under constraint is extraordinary. When you don't have a crane, you figure something else out. When you can't import materials, you work with what's there. Necessity is brutal and an effective teacher. What I also think is we've lost knowledge, a lot of it. And our arrogance about what primitive people would have or could have done is probably slow down the research. Some of these mysteries will be solved. Some already are being solved. And some might stay mysteries for a while longer. Honestly, I kind of hope they do. If you're the kind of person who looks at all this stuff and wants to pull on every thread, you're in the right place. Subscribe, drop your wildest theory in the comments, and I will see you down the next rabbit hole.